My name is Ramkumar. Today I'm going to give a lecture on Introduction to Embedded System and Internet of Things, and start with the basic 8051 microcontroller. And 8051 microcontroller, there is an important peripheral called timer, and we do programming on a timer, and I'm going to demonstrate the timer programming with the help of Kale software. So this is the quick outline of my presentation: Introduction to Embedded System and IoT, Components of Embedded System, how to programming a microcontroller, 8051 microcontroller feature. We start with the basic 8-bit microcontroller, and programming 8051 timer with the help of embedded C, and I am going to be demonstrate of timer with the help of Kale software, and finally I am going to give the summary of this presentation. So embedded system, as all we know, the embedded system is a system which is going to be perform only one task, either with the help of microcontroller or microprocessor. So the traditional refrigerator or washing machine you can take, we are not adding much intelligence to improve the function of the device. So here if you want to add the computational intelligence to improve the overall function of these devices like refrigerator, printer, washing machine, we need to be use some hardware, either a microprocessor or controller with a piece of software. So nothing but we are using the hardware and software to add some intelligence to these things to improve the overall function of the device, such that we can feel comfort as well as we are going to be save the time. Here we are going to be add one more feature like the internet. It is the Wi-Fi. You need to be control these things through the internet. So add network connection to the device to further enhancement in function. So it will give some more benefits to the user to get feel comfort. So what are the components required to build an embedded system? The basic thing is microprocessor or microcontroller. So microcontroller is a integrated circuit, is an IC, it executes a program. So it is a piece of hardware. So it need to be piece of software fused into the IC, it will execute the program. So what are the three main criteria for choosing a microcontroller? As like that we will not choose the controller. First of all, we can see what are the computational needs required for doing an embedded system. If you want to do any projects with the help of the images or video, so the low performance the microcontroller is not sufficient. So accordingly we can choose the microcontroller which the microcontroller is sufficient to meet their requirements that we need to be taken into the control consideration. And how about the cost, it is effective or not. So what are the software tools are available in the market with the open source, such that you need to be compile that particular program, and what about the reliable sources, and while it is available in the market or not to use that controller. For example, datasheet, if you want to see some information about the controller, so that reliable sources are available in the open source or not, first you need to be check it out. So after that you need to be programmed. So you need to be write a piece of code with the help of either C or C++. So you need to be compiled with the help of some cross compiler to convert that C language into machine code. So place that machine executable code, that is .x, into the microcontroller program memory. So these are the basic components. Other than microcontroller, you require some connectors and input devices like potentiometer, some sensors like ultrasonic sensor or IR sensor, and outputs like LED buzzer or motor or some display devices. So other than that, we require an crystal oscillator, capacitor, resistors, and breadboard. So how to programming an microcontroller? For that we need an programming hardware. So this is an our microcontroller. We can place this controller on this programmer. After that you need to be diffuse the program from host machine to the microcontroller. So this is the way you need to be programming an microcontroller. Externally we require and one programmer is required to program this microcontroller. So what is the use of compiler? The compiler is nothing but the converting the high level language, that is a C I have written here, that you need to be converted into the machine executable code with the help of Kale cross compiler. So the first my advice to those who are doing the project, those who are interested in doing the electronic project, the first you can do it with breadboards. You can take all the discrete components like registers, LED, crystal oscillator, wires and microcontroller. First you can do the project with the breadboards. That will help you to what is that get the most understanding about the components as well as that other functionalities of the components which you are using in your program, in your project. And then you have to be implement the same with the help of the same components. You have to be implement with the help of the printed circuit board. Okay, so now we are going to be start with one basic 8051 controller. So this lecture is fully focused on the timer. So this is a 8051 microcontroller. Everything is inside the chip. These are the peripherals inside the chip. That is, we can other way we can call it as a computer on chip. A CPU, RAM, ROM, IO port, timer, and serial communication port. The timer in this microcontroller, timer play a major role. So where this timer can be used in real time. You can take a washing machine control panel. So how much time for soak, how much time for wash, how much time for rinse, and how much time for dry. So you need to be what is that make the timing for the each events. So you can see the timer over here, the 80 timer over here. So this is the 8051 microcontroller. I am interfacing one 7-segment display. So I want to count the number from 0 to 9 with some time delay. From 0 to 1, in between that I give the interval of for example 5 milliseconds. Every 5 milliseconds I need to be the count from 0 to 9. So this is a 7-segment LED. I have interface with 8051. So the timer not only use it for what is that making a time delay between the two events, as well as the 8051 the timer we can use it as a counter also. So for example, if you want to place this 8051 microcontroller in the car parking system, so I have interface this IR sensor with the 8051 microcontroller. Whenever the vehicle passing this sensor, so it is going to be count the external events. So if the one car passes this IR sensor, the count value is be increased from 0 to 1. If the second car passes from the count value increase from 1 to 2 and so on. So this is the bit addressable RAM, some special function register we are going to be used for making the timer programming. So we can see over here TCON, TMOD, TL0, TL1, TH1, TH0, TH1. So these are the 6 important registers we are going to be used to writing the timer programming. So as all we know, 8051 consists of two 16-bit timers and counters. The one timer we can call it as timer 0, another one is timer 1. So the timer 0 the comprises of TL0 and TH0 and make it as one 16-bit timer. The another one with the help of TL1 register and TH1 register, we make it as a timer 1 the register. So the total two 16-bit timer and counters. So this is the important the register TMOD. So we can configure this register such that whether we are going to be use the timer as a timer or counter. So we can see over here this lower byte they can specify especially the dedicated for timer 0, and this higher 4 bits higher 4 bits they can utilize for timer 1. So there are 4 modes of operation you can see over here. We can configure with the help of this M0 and M1 bit whether you can operate your timer in mode 0, mode 1, mode 2 or mode 3. And this is a gate control, we can keep it as always set. And C/T, this is a very important bit whether you need to be make the timer as timer or counter. If you are placing this particular bit as C/T bar is equal to 0, it will work as a timer. If C/T bar is equal to 1, it will act as a counter operation. So this is the TCON register. These lower 4 bytes we can dedicate it for the interrupts operation. We are not going to be using this timer. So the higher 4 bits we are going to be use it for the timer operation. We will come to know. So what are the use of each and every bit of this TCON register of this higher 4 bits. So this is a timer and counter. This is the internal the structure of the timer and counter in 8051. So where we are going to be get the how to generate the time delay. The main objective of the timer is what is that you need to be generate the time delay. For example, 5 millisecond delay you want, or 10 millisecond delay you want, based on our requirement or user what is that customer requirement. You need to be what is that generate the time delay. So with the help of the internal the crystal oscillator or external crystal oscillator, we need to be generate the time delay. So the inside there is a divided by n network. Whatever the frequency generating from the crystal oscillator, it is going to be divided by 12. That frequency is coming over here. So as I said, C/T bar is the important pin in T-mod register. You can configure it is 0, it will act as a timer operation. If C/T bar is equal to 1, it will act as the timer act as the counter operation, perform the counter operation. So this is a TCON register. As you see here, this is a TR0 and TF0 is for timer 0 and TR1 and TF1 for timer 1. As you can see over here, the TR1 is an important pin, important bit as well. If you can make this TR1 equal to 1, you are going to be what is that start the timer. So it is a very important control bit to start the timer. So you can see the control over here. This is connected to the AND gate. So the another pin, the gate, always we can make it as 0. So the complement of this gate input is if you giving a 0, you can get 1 over here. The output of OR gate is 1. You don't need to be worry about this INT1 pin for doing this timer operations. So output of this OR gate is 1 and TR1 is equal to 1. So output of the NAND gate is 1. This switch is going to be closed. The timer is going to be start. Once this TR1 is equal to 1, the timer is going to be start. So it is a 16 bit. It is going to be count from 0000 to FFFF. Once it will reaches, it is going to be get overflow. When it goes overflow, this TF1 bit is going to be set. This TF1 bit is placed in TCON register. So now we are going to be do the programming with the help of 8051 timer. So there are 4 modes of operation. Timer mode 0, mode 1, mode 2 and mode 3. Mostly in many of the applications they are using mode 1 and mode 2. So mode 1 is a 16-bit timer, mode 1 is a 8-bit timer, it is a 8-bit auto reload. So here we are going to be discuss about the mode 1, it is a 16-bit timer. So what is the problem statement we took? So we are going to be assume our crystal oscillator frequency is 11.059 MHz. So we need to be write a program to generate a square wave of 50 millisecond on a pin 2.3. So pin 2.3 is the input or output port. In that particular port, a particular pin, you need to be generate the square wave with a time period of 50 millisecond. So on time period is 25 millisecond and off time period is 25 millisecond. Total on off is 50 millisecond. This time delay is going to be generated and has to be generate that particular square wave on P2.3 pin of 8051 microcontroller. So before that, so what is the value I need to be load in this TL1 and TH1 register, so such that the 8051 timer is going to be generate that desired time delay. So how to find out the values which we need to be loaded into the timer of the two register, that is TL0 and TH0. So we are taking the crystal oscillator is 11.0592 MHz. Okay, this so after that 11.0592 MHz, it is giving feeding to divided by 12 network. So the given frequency is divided by 12. The rest of the frequency is going to be what is this to use it for generating the delay. So as you can see over here, so 11.0592 megahertz divided by 12, you are going to get 921.6 kilohertz. So if you want a time, you can take the inverse of frequency, you will get a 1.085 microsecond. So divide the desired time delay by 1.085 microsecond to get the desired n value. That value you need to be loading TL0 and TH0. So what is that? Here we can see if it is a 50 millisecond, take a off time period, that is 25 millisecond, you need to be that particular time delay, we need to be find out the value n. So 25 millisecond, so divided by 1.085 microsecond. Why it is 1.085 microsecond? The input crystal oscillator is 11.0592. So that is divided by 12, you are going to get 921 kilohertz. You take a inverse of that frequency, you are getting 1.085 microsecond. So our desired time delay is 25 millisecond, that is off period. The on period is 25 millisecond. So that's why this is our desired time delay. So you need to be divide this time 25 millisecond divided by 1.085 microsecond. So we are going to get okay 23,037. So this timer is mode 1. So it is a 16-bit timer. So the maximum, the decimal value is 65,535. So you need to be subtract this value 23,037 with this 65,535 plus 1. We are not going to be count from 0. That's why you are adding this 1. So we are going to be get 42,499. So this is in decimal. So this is our n value. So this n value is again converted to the x. So we are going to be get 85D1H. So this is the value we need to be loading TL0 register and TH0 register, such that the timer is going to be generate the time delay of 25 millisecond. So D1 you load in the lower register, that is TL0, and A5 you load in TH0 register. You load A5 and D1, the 8051 timer is going to be generate the time delay of 25 milliseconds. So now we need to be write a program with the help of embedded C such that you are going to be generate the time delay of 25 millisecond off, 25 millisecond on in the pin P2.3 of 8051 microcontroller. So this is the program. So the first you need to be what is that declare the header file. So as include reg51.h. So why we are using this header file we are including in this program to whatever the register special function registers are there in 8051 that we need to be used in the program. For example, you can see over here tmod is a one special function register. Suppose I want to use this register in the program, you need to be include this header file over there. After that, I am using only one bit in port 2, that is the pin number P2.3. A single pin only I am using. That's why I need to be use the data type S bit. S bit means we are going to be define the single bit. That P2 cap 3 is assigned to my bit. This is a variable. You can use A, B or C, whatever the variable you want. You can assign that particular pin P2.3 to my bit. My bit is a variable. So I am writing one delay function. So why I am writing this delay function? So 25 millisecond on. After that I need to be complement, and 25 millisecond I need to be off. So that's why I separately writing the delay function over here. You need to be declare this delay function above the main function that you need to be taken care. So void T0 M1 delay, that is the function name of. So above the main function I need to be declare the function. So after that I am writing the void main, this is the main function. So I need to be configure tmod register. Tmod register I need to be configure. So which timer we are going to be use? Okay, here we are using timer 0, and which mode we are using mode 1. So such that we need to be configure this tmod register such that the 8051 understood that the timer 0 is selected with mode 1, that is a 16-bit timer. So that's why the configuration of T mode register is very important. So I have loaded with 0x01. It means that it indicates that I have chosen timer 0 mode 1 operation. While of 1, it is an infinite loop. So inside that the my bit is nothing but I have assigned pin P2 cap 3 is assigned to my bit is equal to complement of my bit. Why? Because 25 millisecond I make it as low, the next 25 millisecond make it as on. I need to be take a complement of it. So after that I am going to be take a colon delay function T0 M1 delay off. So I am going to be call this delay function. So here return a program for 25 millisecond delay. After that come back over here, this is an infinite loop, it is going to be complement again for 25 millisecond, again 25 millisecond it is going to be call this function and generate the time delay of 25 millisecond and so on. So this is the main function, declare a T mode register, it is for which timer, which mode, and write one infinite loop inside the main function to complement that particular pin, what I am sending the value on P2.3, 25 millisecond on, calling the delay function and execute this to create 25 millisecond delay, and again come back to the main program and complement it and generating 25 millisecond time delay. So I come over here in the red color which I have written the program for delay. So already we have found the values, what value need to be loaded in TL0 and TH0 such that it is going to be generate the desired time delay 25 milliseconds. So here you can see TL0 I have loaded with 0xD1. So there is two ways to load this hexadecimal number into TL0, either 0D1H or else we can use 0xD1. Both are it is a valid way to load into TL0. And TH0 you are loading 0xA5. So I have loaded two values into TL0 and TH0 such that it is going to be generate 25 milliseconds. So I need to be set the bit TR0. Why? Because it is very important. As you have seen here, the TR1 for timer 1, TR0 for timer 0. If you are making this particular bit as 1, so this bit is available in TCON register. So TR0, this bit you make it as 1, then only the AND gate output is 1, the timer is going to be, the switch is going to be closed, whatever the frequency, the clock frequency you are feeding, such for that frequency, that the timer TL1, TH1 register is going to get incremented. So that is the thing. After that I need to be check, okay, the TF0 flag is set or not set. If it is not set, the program control stays on the same line, okay, until TF not is equal to 0, the program stays on this line. It means that the timer is going to be count. What value I have loaded in TL0 and TH0, A5 and D1, next clock A5 D2, the next clock A5 D3 and A5 D4 and so on till FFF. Once the TL0 and TH0 reaches to FFFF, overflow flag will set. And it comes out of the this particular line and making the TR0 as 0 and TF0 as 0, and again come back to the main program. The where it will stops, again the while of 1 is going to be execute and make a complement, again you are going to be call this particular function. So I am going to be demonstrate this program with the help of Kale software. What we have discussed so far, the 8051 timer 0, that program has to be demonstrated with the help of Kale software. So in 8051, in pin number 2.3, we are going to be generate the square wave with the on period of 25 millisecond and off period of 25 millisecond. That square wave I need to be generate with the help of the Kale software. Just switch over to the Kale platform, and you need to be write that program. You just go to new over here and you need to be type the program. So here already have to copy that program. I will paste over here. I have pasted. Now I want to save this file. So go to file, save, where we need to be create a folder in the D8051 folder we created. Inside that only need to be saved with the .c extension. So I have created the file name as program with .c extension, because we have written with the help of embedded C. So .c extension we need to be placed over there, then we need to be save it. So now need to be add that particular program under this project name, that is sample. So for that, the source group 1, so right click, add existing file. So you can see over here, so all files. So this is the program. Okay, C source file, just click and add. So you can check over here under that 89C51 target, the program.c has to be added. Now I want to compile this program. I need to be check whether any error is there in our program or not. So just click this button, that is a translate. So you can compiling the program.c. So you can see 0 errors, 0 warning. So after that I need to be build or fuse this program into our target. So build target files. You need to be build this program.c into target device 8089C51 which we have chosen. So build, again you need to be rebuild it. So then we want to see in pin number 2.3 whether 25 millisecond the time delay get generated or not. So before that you go to this option for target. Our crystal oscillator frequency which we have chosen is 11.0592 MHz. It is the frequency we have chosen. For that input frequency, we need to be generate the delay of 25 millisecond on, 25 millisecond off. Just click OK. Then you go for start debug option. Just click OK. So you can see there are different peripherals present in 8051 like interrupts, IO ports like 4 ports, serial communication for serial transmission and timer. Here we are going to be see the waveform with the help of logic analyzer. Here there is a logic analyzer option is there. You just click the top logic analyzer. Just you have to adjust the screen to see the output graph. And just go to setup. So you need to be set which pin we are going to be observe the output. So P 2.3. I have written a program. You have see the program which pin P 2.3 only I need to be generate that particular output. So P 2.3 and just click OK, close it. Now you go for this is the run button, run it. So here you can make the transition from 0 to 1, not 0 to 255. Again go to setup. So instead of the maximum is FF, you can make it as 1 and just click close. So now you can see some output we are getting. Now I have to be adjust it. I want to see the output graph exactly. You can stop it. And there is a cursor is there, you can click where the on period it is going to be start. So it start from here. So click over here and until this end. So click it and you can see the time over here. For example, I am keeping this okay till here. Yeah, you can see delta, what is the time it is showing, 25.5306 milliseconds. So this is the on time. So again off time also it is a 25 milliseconds. The total on time to off time is 50 milliseconds. We have discussed so far it is a timer of 8051 microcontroller. The timer play a crucial role in the various embedded application. The particularly we have chosen today as the washing machine. You have seen. Um, Suppose if you want to wash, we need to be set the time. So what clothes we have kept inside the washing machine, for example, kids wear or sports wear. So if it is a sports wear, you have to be set the timing. For example, 1 hour 45 minutes. So there are in between 1 hour 45 minutes, the four events to be occur. One is soap, another one is wash, another one is the rinse, another one is spin. In between the event, you need to be get the surf, get a inlet water. After that, you need to be soak it. After that, outlet that soap water. Again, you can take a fresh water, wash it, and rinse it, and you have to be drain it. So for each event, you need to be what is that fix the some desirable time delay. For that, this timer play a crucial role. Thank you.